All right, so this is called a three-dimensional coordinate system. Okay, that's what 10.1 covers. The good news is it's relatively easy. The only thing is like the idea of the coordinate points itself is abstract, but once you understand that, the formulas that you have to know in this section are super easy. Okay. So first thing is that to identify a point in space, so we're saying space because we're now taking something, instead of just going up, down, right, and left with it, we're going forward, back. So you're adding the third dimension. In order to do that, you add the third dimension, and the geometry of this three-dimensional model is called solid analytical geometry. So when you hear the term analytical geometry, that's what it means. It means you're bringing in a third variable or a third dimension, which is z. So you can construct a 3D coordinate system by passing a z-axis perpendicular to the x and y-axis that we already know. And the figure below shows the positive portion of each coordinate axis. So if I zoom in on this, notice that the x and y and z are labeled, and the x is now coming forward and back. So our former x, which would have gone left to right, we're now going forward and back. The y is going right to left. The z is going up and down, okay? You can rotate this around, like you'll see. I have a web tool that lets you kind of rotate it around, but when you see something like a static image and you see those three axes drawn, the x will be forward and back, the y will be right and left, and the z will be up and down. And that's important because there's going to be different ways that you're going to be asked to find out information about these coordinate points. One is if you're given a point, plot it. Another is if you're given a graph, tell the coordinates of a point. And the third is to describe the coordinate point with words. So if I said forward or back, that implies your x-axis. If I said right or left, that's your y. And if I said up or down, it's z. The words are important there, okay? The coordinate system, or the coordinate plane, separates the 3D coordinate system into 8 octants. So these are called octants. It's just a vocab term. I'm not going to test you on that, but that's a vocab term. The 3D coordinate plane almost looks like, if you separate it into an octant, it's like a 2x2 Rubik's Cube, like if you could picture it, okay? Again, your three axes, which this one has forward and back, right and left, top and bottom, would be how those are split up. So instead of it being 4 quadrants, because it's a 2x2, it's 8 octants because you have that additional space. So if you look at what's here, okay, this is all just the first octant or the positive octant. So we moved forward. So we said that the x values are going to be forward or back. So if I say a point moved forward, I mean it's a positive x. If I say a point moved back, it's a negative x. If I'm going right and left, now we're talking about the y coordinate. If I say right, it's a positive, and if I say left, it's a negative. And those are the y coordinates. And then last but not least is the up and down. And this is your z coordinates. If it's up, it's positive. If it's down, it's negative. So again, we'll talk about it some more tomorrow, but you would need to know if I said a coordinate point is back 2 units, left 3 units, and up 4 units, that is -2, I don't remember what I said second, -2 and positive whatever the last thing was I said, okay? So those things are the words you need to know. Forward, back, left, right, up, down. In addition to the actual coordinate points, which will look something like this. So example 1 says to determine which is the point, 2, -3, 3 in the coordinate plane below. We're actually going to name all these coordinates because we might as well get the extra practice, okay? Left is, well, left is a -y. Yes. And right is plus. Yep. All right, so if I'm going to start with this coordinate point here, the one that's in the top left corner, okay? Here's where it gets tricky. When you're looking at your x and your y, it should come like literally from your axis, so that should be easy. The x is the forward back. So I got here by going out here, right? Which was the second tick mark moving forward. So my x is a +2. Then I got the y coordinate, and the y goes left to right here. I got the y coordinate by going left 3, which means my y is -3. And then here's the tricky part. This is tilted forward. So I can't come straight across here and say this is 3. That's not the way it works, okay? So you have to picture as though it was tilted forward. You cannot use your horizontal like that. The easiest way, in my opinion, to do this is see how much, like see how forward you came like that. This is 2 scoops, kind of like that. This would be the same 2 scoops, which means I'm going 1 more, and that would be 3. So use the ones that you know for sure and count those little, like you could do what you want with it, but like I'll do like a scoop, okay? And then use that to estimate how high up or down you're going. I cannot come like this and say that that's 2.5 because that's the horizontal. That's not the way it works. This was tilted forward, which means that that point should be also shifted. So this is the point that they asked about, but we're going to do the other ones, okay? So if I come to the one on the right here, my x is the forward back, right? And you went back 2, so my x is -2. My y is the green one.
They're always going to have the dashed line, right?
Usually, but you're going to also have to plot this, like without, like the other way around, which you'll see next. Okay, the y comes out of where? What y is that? 6, and it's to the right, right? So it's +6. Now, if this was 2, this looks about the same distance, which means my z, I'm going to assume is 2. Now I'm going to come to this guy here, the blue dot. What's the x on the blue dot? 1. I came forward 1. What's the y? 4. You went to the right 4. What's the z? 0. You don't go up or down at all. And then this last point, the x is 2, the y is 2. So if I'm saying like this distance is 2 or this distance is 2, this would be about 1, 2, 3. So it's -3. If I was to compare them, this should be about the same as this distance. It's just going the other direction. Questions so far? Because you're coming, so here's my y-axis here. The little pink line is literally coming from that second mark. I wrote all over it, but there's a line under there, right? So this dashed pink line, hello, is where y is 2. Does that make sense?
Oh, okay.
Okay, I wrote all over it, so hard to see. Example 2, you're plotting on the, so this is, I'm giving you the point and you are plotting it on the axis. So again, x is forward and back, y is right and left, z is up and down. So if I go -1, 3, 4, I'm going in what direction for the -1? Back 1. No. Yeah. +3 says where? To the right 3. So 1, 2, 3. I'm going to come off of this guy. So 1, 2, 3. Now I'm here. And then my z is 4. So I'm going to use that same general scoop. Okay. 1, 2, 3, 4. I don't need this to be exact. If you're drawing it on here, it should be around about the same. And you will give me those little marks to show how much you intended to go up or down. So if it's a graphing question like this on your test, then you're going to show me the little, either like give me dots to count each one or little scoops, whatever it is, but show me what you indicated to go up or down.
So it doesn't have to look.
It's not going to be perfect. It should be around the same. Like if your C's down here, obviously there's a problem. But if it's where in the general vicinity of where that one is, that's fine.
Isn't that like around 5 on the z-axis?
You can't go horizontal though. It's dipped forward. So you're going just up from where you ended. All right, D, 1, 3, 2. So we're coming forward 1, we're going right 3, and we're going up 2. So it's about there. Again, it's not going to be exact, but you're showing that you went up 2. It's not hard, it's weird, right? That's it. And then E2, -1, 4. You're coming forward 2. You're going left 1. You're going up 1, 2, 3, 4. And there's your E.
So it doesn't have to be
No, it should be close. In the right quadrant-ish if you're looking at it from the front. But if you show me the 4 scoops, that's all I need. Yep. Good. All right, now we get to the formulas. Okay, so there are 3. You already know these formulas because they are midpoint, distance, and circle. We are just adding a 3rd variable. So the distance formula we know as x2 minus x1 squared plus y2 minus y1 squared. We're just now adding a z2 minus z1 squared. So you already know this. You're just adding on the z's. And then the midpoint formula, again, we normally add the 2x's divided by 2, add the 2y's divided by 2. Now we're adding the 2 z's and dividing by 2. So this answer is going to be an x, y, z coordinate where this will either be a square root of a number or an actual number if you can simplify it. Correct. That's it. All right, so this says find the distance. Yeah. All right, this one says find the distance of the midpoint. So A, let's do distance. Square root of 1 minus 0 squared plus 4 minus 1 squared plus negative 2 minus 3 squared. I get this. No. Square root of 1 squared plus 3 squared plus negative 5 squared. 1 plus 9 plus 25. Square root 35. It is x2 minus x1, but it honestly doesn't matter as long as you're consistent. If you're doing all the firsts minus all the seconds and all the seconds minus all the firsts, it doesn't matter. Because you square it. It's not like
consistently decide to mess up.
Decide not to mess up.
Yeah.
No.
He said to mess up.
No, I corrected him. All right, so square root 35 would be 5 and 7. Nothing repeats. Can't be simplified. I keep that answer as it is. Obviously, if it can, you need to. And then B is your midpoint, so we add them. 0 plus 1 divided by 2. 1 plus 4 divided by 2. 3 plus negative 2 divided by 2. 1 half. 5 halves. 1 half. All right, last equation, okay? And this one, this you don't have to remember as much as what's on the next slide. But this is where the, guys, this is where the equation come from. So if you think about it, a 3-dimensional circle is a what? A sphere. So if I took my circle formula, right? Remember that's, you get that from saying the distance from the center to the side is a radius. Then all you're doing is saying the distance from the side of a sphere is its radius, because that's the same thing. And which means we add on another variable, okay? So the equation you need to know is this one. It is very similar to the circle one. The circle one was just the x's and the y's. And now we add on the z's. And the x goes with the h, and the y goes with the k, and the z goes backwards with the j. Don't ask me why, okay? So it is x minus h squared plus y minus k squared plus z minus j squared equals r squared. All right, so this one says find the standard equation of the sphere with a center of 2, -4, -5, and a radius of 3. So I just do x minus 2 squared plus y minus a -4 would be plus 4 squared plus z minus a -5 plus 5 squared equals the r squared, which is 9.
R squared, which is 9.
Easy stuff, right?
Wow. Kevin will still get a 4.
All right, last one. Find the center and the radius of the sphere given by. Now this time you get a full equation. This is not in standard form. How do we put it in standard form? Complete the square. There are there are 3 variables. So I'm going to group the x squared. I'm going to do the, it's still a square. You're still completing the square. You're just doing it 3 times. No, the square is, the term complete the square means, no. The term complete the square means finish each one of these perfect square trinomials. That's what complete the square is. So it's still completing the square. All right, the good news is, guys, these don't get too hard. Like there's not even any, like there's no coefficients on these. They're all nice, pretty even numbers. So this shouldn't be terrible. All right, take the 4, divided by 2, and square it. I would add what? Take the 4, divided by 2, and square it. 4, and I add it to both sides. I take the -2, I ignore the sign, right? So 2 divided by 2 squared. What am I adding to the y's? 1, and add it to the other side. And 8 divided by 2 squared, 16. Good, add it to both sides. And then we factor all 3. So it would be square root, sign from the middle, put it in parentheses and squared. Square root, sign from the middle, put it in the parentheses squared. It's literally square root the first number, square root the last number, take the sign from the middle number, put it in the parentheses, and square it.
You already have the numbers that you squared.
And then add these. -6 plus 1, -5 plus 16, 11.
Square, so you take the first...
Square root, first one.
Right, so
Oh, it's -10.
Square root.
X, you just take the x out. And
Square
then
root.
put it there, and then take
Sign
the
from the middle.
I was never taught that.
Oh my
God.
Kevin, she taught
All right, that's it in standard form, though. What's the question asked for? Center and radius. What's the center?
-2, 1, -4.
Good. What's the radius?
Square
Square root of 11.
Oh, yeah.
Easy, light work.
Yes.
We're going to take